Summary by Kristaps Innus. For home reading How to Build CPU, I have chosen two articles: How Microprocessors Work and the Complete Guide to How to Build a Computer from Scratch. In his article How to Build CPU, Marshall Brain explains basic principles and logic behind microprocessors. Brain covers such topics as brief history of Intel, microprocessors logic, memory, instructions, performance, trends, and 64-bit microprocessors. He starts by stating that microprocessor, also known as CPU, is a complete computing engine that is fabricated on a single chip and it can be found in any smart technology. The first topic what Brain covers is a brief history of Intel microprocessors. Brain points out that the first microprocessor was the Intel 4004 at the beginning. Every following microprocessor was just an upgraded version of Intel 4004. Before Intel 4004, computers were built either from a collection of chips or from discrete components such as transistors. As a result, the 4004 powered one of the first electronic calculators, but the first microprocessor that were made into home computer was 8-bit Intel 8080. Brain believes that the first microprocessor to make a real splash in the market was Intel 8088, which was incorporated into IBM PC. Processors such as Pentium 2 as well as Pentium 3 and 4 also were just an upgrades of Intel 4004. As Brain states, Pentium 4 can execute the same piece of code that was originally made of Intel 4004, but it could do it 5,000 times faster. In the second chapter, Brain talks about the microprocessor's logic. A microprocessor executes a collection of machine instructions that tell the processor what to do. Brain points out that the microprocessors based on these instructions perform three basic things: perform mathematical operations using arithmetical logical unit, moves data from one memory location to another, makes decisions and jumps to a new set of instructions based on these instructions. Focusing on the microprocessing logics, Brain also covers certain logical components of CPU such as address bus, data bus, read and write lines, clock lines, reset lines. Third topic Brain covers is microprocessor memory. Interestingly, for me, was that the processor is not just mainly connected with RAM, but also with ROM, read-only memory. A read-only memory chip is programmed with the permanent collection of the preset bytes in PC, and in PC it's called BIOS. To better understand how it works, Brain explains that when the microprocessor starts, it begins executing instructions it finds in BIOS. The BIOS instructions do things like test hardware in the machine and then goes into a hard disk to fetch the boost sector. This boost sector is another small program and the BIOS stores it in RAM after reading it off the disk. The microprocessor then begins executing the boost sector instructions from RAM. The boost sector program will tell the microprocessor to fetch something else from the hard disk into the RAM, which the microprocessor then executes. And so on. This is how the microprocessor loads and executes the entire operating system. In next topic, Brain covers microprocessors in instructions. The collection of instructions is implemented as bit patterns, each one of which has a different meaning when loaded into instructor register. There is also showed many simplified examples how assembly language works in the RAM as well as in ROM. In the next chapter, microprocessors, performance and trends, author underlines the importance of transistors. For a processor to become more faster, there is a need for more transistors. For comparison, Intel 8080 had 6,000 transistors, but Pentium 4 had already 125 million of them. In this chapter, author introduces such terms as pipelining. In pipelining architecture, instruction execution overlaps. Microchips with More transistors allow this kind of an architecture, which generally increase the amount of instruction that can be completed with one clock cycle. Brain continues with explanation of the newest trends. Author thinks that one of the newest trends, 64-bit processor, will be implemented in all the houses after a decade. Continuing with 64-bit processor, author states that the need for 64-bit processor is quite obvious, because a 32-bit processor possible usage of RAM caps around 4 GB, but in foreseeable future 64-bit RAM usage won't be capped so soon, because Brain explains 2 powered by 64 bytes of RAM is something on the order of a billion gigabytes of RAM. There is still different thoughts on this subject. Is there actual need for a 64-bit processor at home? Well, for a normal office worker who usually use internet for emails, browsing, and Microsoft Word, the answer is no. But for those who edit videos, render them, play high-end video games, use virtual machine, the answer is yes. But quite many of applications still do not benefit from 64-bit processor. In conclusion, Brain gives a list of other useful links that can be used to learn even more about computers and even more in depth about CPU. In Next, in his full guide How to Build Computers from Scratch, Whitson Gordon explains basic principles behind all separate computer parts as well as explaining what you should consider when buying a new computer. Gordon covers such topics as hardware basics, how to choose separate parts, building the computer, and installing operating systems. He starts by introduction of terms low, medium, and high performance computers to describe computers of different target audience and to make certain picture where you're headed. After that, he's explaining all the basic hardware that you can find in any home computer, listing processors, motherboard, casing, RAM, graphic card, hard drive, optical drive, and power supply. After discussing this, he moves to the next main topic, choosing and buying your parts. In this chapter, he focuses more on what you would need to look for when actually you would be ready to buy a computer. Gordon goes in more detailed information about all the separate parts and points out which parameters we should pay attention when deciding on buying these things. He makes it very easy to understand what must be considered. Let's take for example the hard drives. For example, hard drives you should look for its size, speed, and solid-state drives. Besides these parameters, Gordon also provides a list of brands to watch for when buying separate parts. Author moves to the next chapter where the building the computer is discussed. This chapter covers how to mount motherboard, install the processor, RAM, etc. Mainly focused on giving real instructions as I would assemble the PC in the same moment. That would be so helpful if I ever decide on building my own computer. In the next chapter, Gordon covers the meaning of operating system and how to install it, and the need of configuring BIOS so the computer would boot from CD/DVD room. In the conclusion chapter, Gordon gives many useful learning materials for those who want to learn more in depth about building computers. Well, in conclusion, by comparing these two articles and what they have given to me, I consider Marshall Brain's article to be more of my taste, and information felt fresh, with all of examples and explanations, and the language was kept at minimal difficulty level but still challenging for me, so not making it boring. Whitson Gordon's article I found to be really interesting at some point, and the simplicity of it made it easy to read, but therefore it didn't give such a satisfaction that I was expecting. Overall, two articles was quite interesting and gave me so much interesting information about computers in general, as well as what actually CPU is and how, and now I know some basic working principles behind it.